All right, hello folks. Today we're going to talk about redox reactions. This is going to be a part of the next unit, and if you've taken the AP exam, this is going to pretty much better. This is part is going to be on it. So how this is done in nature. This is what we call single displacement reaction, where we have a metal and something else happening, and water can donate a proton to react with lithium, and what we have is this reaction. Lithium is a metal, and here's our water, and we get lithium hydroxide plus H2. And this is the question: is how does this react? And this is, let's see, whoops, nope. So this is what happens. So we have water, and we got, remember, water is polar, so this is slightly negative up here, and this is going to be slightly positive down here. And now lithium is a metal. It's going to react with the negative OH. And remember, this dissociates a little bit. So you got lithium, and then you got this one electron. You got H plus OH minus. And the hydrogen will take this electron away. So make lithium positive, and you got this OH negative, and those two are going to combine together. Now what we have is that we got this hydrogen by itself, and this is a very reactive species. And so what will happen, it will come in and take this away and bind with the hydrogen to form H2 gas. And now we have a bond here, and this is very reactive, and this is going to react with the lithium and pull this electron away, so we just have LiOH, and we've got two of those now. Again, this is a very simple reaction. It's very reactive because it occurs on the surface. So this is our lithium metal. It's going to occur on the surface. The more pieces of aluminum you have, the faster this reaction is going to go. So if you see people drop in big blocks of things, the reaction is going to occur on the surface. What you need to do is give about half a dozen pieces to have this react. And this is very fast and very exothermic. We'll get a nice little boom out of this, actually, as we go. So water is donating the proton to react, as we see here. And this is why. And each of these metals have a different way to react with water. And this is just a and here we go. This is the summation of what I just talked to. H plus is highly electronegative, wants the electron. Pull off the electron off of lithium. Lithium becomes a cation, and it goes away. Repeat with another water molecule, and the two hydrogen atoms are going to react to form hydrogen gas. And boom. And this is going to occur first. And we have this. And more likely, this is going to repeat itself over and over again. This does occur, but very slowly. It's this part right here that's going to occur fast. And we just done this. So reaction trends, so we've got these alkali metals. We've got lithium, we have sodium, potassium, cesium. I think we've got rubidium, then cesium. So what happens as we go down? These guys are getting bigger. If you look at electronegativities are going down. Hydrogen is going to be very reactive with these. Water is actually going to be very reactive. So as we go down, since these have a lower pull on the electron, we expect to see a faster reaction, a more rigorous reaction. So here are the answers: effective nuclear charge. So as we go down, lithium has a higher nuclear charge, what we call C effective, than sodium. So this is going down as we go down the periodic table. Distance from the nucleus, as these atoms are getting bigger and bigger and bigger, so the electrons are more farther away, it doesn't see the pull, and the energy levels are actually, these things You guys seen these before. You know, as we're going up in energy, hydrogen's down here. So it is easy for, if we have an electron in this orbital, it can easily go down to that one, and we'd like to go down to that one and give off energy. So that's how it works. So these elements are all highly reactive with water. Lithium, potassium, barium, calcium, sodium, you know, basically column 1 and column 2. Now, some of these need to have an acid to react, or steam. Magnesium, because it's smaller, it's above calcium on the periodic table. So since this is smaller, has a higher electroeffective nuclear charge, it's going to need a little bit more acid or steam. Basically, very kinetically fast water molecule. All of these need these acids. Now, what the acid does, it produces more and more H+, and that helps take the electron away. With water, remember, hydrogen is bound. It only has one, in pure water, the amount of protons is 1 times 10 to the minus 7. So what we're doing is increasing the amount of protons in solution when we add acid. And these will react with the acid to produce hydrogen gas. These, cobalt, nickel, will only react with acid. Did I put copper twice? No, I didn't. That's chromium. And these will not act with H+. You need something else to react. They will react with nitric acid. And this is a different procedure, chemistry altogether. And we won't go that. You'll get into that when you're freshman or if you decide to become a chemistry major. We're not going to talk about that now, just say it does react with nitric acid. So copper does not react with HCl, but will react with nitric acid, which is HNO3. Gold is actually more, and platinum are actually more resistant to nitric acid. And the only way to dissolve these two is actually what they call a mixture of hydrochloric and nitric acid called aqua regia, royal water, and that will dissolve these two. So how this reacts is actually the electron moves. And this type of reaction is called oxidation reduction. And 95% of all reactions can be classified as a redox reaction. And we're looking at the electron move from one place to the other. And we've got to do some definitions first. And this is a little bit circular, so just pay attention. Reduction, a process of the target atom to gain electrons. So in these so the hydrogen is going to gain electrons. So this is a reduction going from H plus to H. And to do that, you need to add an electron. This is what we call reduction. Oxidation, we're losing electrons. So lithium goes to lithium plus an electron. This is an oxidation reaction. The oxidation agent is the atom taking electrons. Yeah, this is the oxidating reagent. And the atom losing electrons is the reducing agent. A little bit circular, but this is how the definitions work. So to do this, we need to know what the oxidation numbers are. And that's a number expressed as the chemical state of the atom with the assumption that the molecule has nothing but ionic bonds. This is important, is this assumption. Because we know that carbon dioxide is all covalently bonded. But carbon has an oxidation number of 4 in the molecule, while each oxygen has a -2. And we'll talk about more on this later. And here are the rules. And I'm going to stop right now because I have another set of slides with these rules as well. And here we go. Just a summary of this. I have another slide which explains it a little bit more. And know the charges of the anions. And this is going to help you as well.